Hey, what's up, everybody? This is Andrew Lahano, and this is my project 2 for DVC's Math 142 Elementary Statistics class for Professor Chris Bradley. Hope you guys enjoy.
It's the thought of being when your heart's just like a drum, beating louder with nowhere to guard it.
Alright, everyone, so I will teach you about misleading graphics. And by misleading graphics, I mean like when graphs and other visuals mislead the viewer and present information that is skewed or can confuse the viewer, bias the opinion of the viewer in order to gain something that the source wants you to do, like make a certain choice, like for politics, or to buy a certain thing, or to show something that's good or bad. So we'll get started here. Alright, so I read an article called 5 Ways Writers Use Misleading Graphics to Manipulate You by Ryan McCready, and the 5 ways are as follows. So 1. Omitting the baseline. 2. Manipulating the y-axis. 3. Cherry-picking data. 4. Using the wrong graph. And 5. Going against conventions. So, number 1, I will use an example with 2 graphs left and right, for each of the ways that people try to manipulate you with graphs. So on the left, you see that these are 2 graphs about if Bush tax cuts expire, and they show the current date now and on January 1, 2013, what would happen if they expire. On the left graph, you see that right now the tax rate is at 35%. That's what it says. But on January 1st, 2013, it says it'll raise up to 39.6% if Bush tax cuts expire. What they did here, you can see like visually, that looks like it's 5 times more than, like 5 times more of an increase, right? But actually what they did here to mislead you is they omitted the baseline, which means they did not start at 0 on the y-axis. As you can see here where I circled in green, they actually start at 34, which makes you think that the jump from 35% to 39.6% is actually huge. But on the right graph, which is more correct and represents the data a lot clearer, is it starts at the baseline, which is 0%. You can see the increase from now, which I assume is a date both before January 1st, 2013, and if the Bush tax cuts expire, 39.6%. It shows us like a 4.6% difference. Both are 4.6% differences, but it shows that it's just a slight increase, nowhere near as significant as the left graph. So that's very misleading. So why would they want to present this data like this on the left? Because maybe they're trying to say, hey, we want to say that Bush tax cuts, if they expire, that's a bad thing because then tax rates increase by so much. And they want to convince voters, maybe if Bush's term is ending, to continue to maybe vote for a Republican leader so that they keep that Bush tax cut. Because if it were a Democratic leader, perhaps they would expire that or not renew that tax cut or increase taxes or something. So yeah, they want to keep maybe a certain leader in office or elect somebody a certain way. Who knows what the reason was, but manipulating the y-axis. So on the left and right graphs, we have the average annual global temperature in Fahrenheit from 1880 to about 2014. So representing, see if there's global warming, right? In the left graph, you can see that the graph looks fairly flat. You can even see I use the green line to convey that it looks, yeah, flat. But why does it look flat? Does that mean there's not global warming going around? Actually, it's because the source, whoever made this graph, manipulated the y-axis and they started from negative 10 degrees Fahrenheit to 110 degrees Fahrenheit. And yeah, that's not a good thing. That's misleading because it makes it look like there's no change at all, but really you'd have to like use a magnifying glass or something just to see if there's actually any change. But if you just look at that graph, people would assume, oh hey, there's no global warming going on, the temperature's staying flat. But looking at the right graph, as opposed to the left graph, we see that there actually is an increase in global warming, or global temperature. From 1880, it starts at about 57 degrees Fahrenheit, almost 57 degrees. And by the end of 2000 or so, it rises up to like 58.5 degrees Fahrenheit. So as you can see, there actually is, on that green line I'm showing now, an increase. So the way that's a more accurate scale for the y-axis. And why would they want to manipulate that? So just because they want to show that there's nothing wrong, maybe with the globe, or whatever data they're trying to represent. Like, oh, they don't want to show a dramatic change in something, or they do want to show a dramatic change. It depends on what it is. All right, moving on. Cherry picking data. So here we have Twitter Inc.'s, or Twitter's stock value at US dollars, represented in two graphs. The left graph is 3 months prior to May 24th, I assume 2017. And the right graph is the maximum span, maybe since Twitter had stock, from 2014 to May 24, 2017. We see here on top of the pink line, it's just ranging from March 1 to May 24th, which is about 3 months. But the orange line is about 3 years or so, right? Yeah, something like that. From 2014 to 2017, at least. But we see on the left graph that, hey, Twitter, it looks like they're doing pretty good, right? Like, in the last 3 months, they've been kind of increasing in stock value, right? According to this green line. Good channel trend. Maybe I should start buying stocks. Or, it's a good time to invest, right? But actually, in reality, Twitter has not been doing so good. Because in the long run, Twitter has been actually declining in their stock value. So look at 2014, their max was about 75 US dollars, and at the end of 2017 or so, it's down to 18 US dollars. So yeah, they cherry picked just data from like 3 months, from March 1st to May 24th, to make it look like Twitter was doing good. And cherry picking data is basically choosing what you want the viewer to see in order to make them bias certain towards a certain thing, right? Alright, using the wrong graph. So what we got here on both graphs is a comparison of 3 web browsers. The web browsers are Google Chrome, Microsoft Edge, and Mozilla Firefox. On the left graph, we got these visuals that look like speedometers, right? And on the right graph, we got a bar graph. The left graph is actually using the visualization wrong, because you see that Google Chrome is only 5% slower than Microsoft Edge, and Mozilla Firefox is 9% slower than Microsoft Edge, right? But you see that little speed ticker mark thing looks like it's almost 25% slower than the speed score of Microsoft Edge. And Mozilla Firefox is even worse. Even though it has a rating of 26,000, which is 9% slower, it looks like it's 50,000% slower than Microsoft Edge with that little speedometer thing it's using, right? So a more accurate way to graph this and compare is to make a bar graph. And you can see on the right, the difference between all 3 web browsers isn't too much. They use the proper baseline, start at 0. They use a nice scale on the y-axis, going up by 10,000 per speed score. And we see that it's just a very small difference. They're almost all equal in speed. So yeah, don't get fooled by that. And why would people want to use this way to mislead others? Maybe just to sell something and say, oh hey, my thing's better, look at this visual, and make the other person assume like, oh hey, yeah, you're right, it is, you have the numbers there, like, yeah, on the left the numbers are correct, but visualizing it, they're showing that it's a lot worse when in fact it's not that much worse. It's only a few percent worse, not even 10% worse compared to Mozilla Firefox and Microsoft Edge. And the last way, the fifth way that you can mislead using graphs is going against convention. So what we have here are two graphs. They are of the United States, of course. The left graph conveys which states have the most STIs, or the STI rate. According to the source, the darker color, the purple, actually means that that is the lowest amount of STIs, or the lower rate of STIs. It also said that the higher the number, which is that 50, you see that, where is that? That 50 on my red arrow over there means that that's the lower rate, which is kind of confusing because usually a bigger number means a higher rate, right? But in this case, a bigger number means a lower rate. So this is super misleading because first, when we see colors as human beings with our human eyes, the dark colors usually catch our eyes first, and they mean density or quantity, right? So we would normally assume by convention that the darker color means there's more of a certain thing, like maybe more STIs in this case, but it's the opposite. So if someone were to look at the left graph before reading into or knowing the full information, they'd say, oh hey, Idaho and Utah have the most STIs, man, I don't want to live there. When in fact those are actually the places with the least STIs and the safest to live. So the correct way to do it is to follow convention, like the right graph. This graph shows a percent change in resident population for the 50 states, and they denote it, or they convey it with the color scheme with green, but the darker green means the higher percent change of population. So you can see easily what catches your eye first, probably Nevada and Arizona. They have 3 times the US rate change, or 39.6 or more percentage, as I've shown with that red arrow. So that is it. And why would somebody want to do this? Just to maybe confuse others or steer away from an issue. Like say hypothetically Idaho had low housing, right? Like they're overcrowded, they didn't have enough homes there, and people wanted to move there. They'd be like, hey, look at this graph of STIs. Look, they're infested with STIs. It's dark purple there. And they'd be like, oh yeah, that's right, I don't want to live there. It'd be unsafe, you know, or I don't know. Yeah, it could mislead information, and it could cause people to change their decisions, or who knows, just maybe some people have bad intentions out there. So that is everything. Hope you guys enjoyed. Thank you for watching. Peace.